Hello, welcome to I Love Chemistry with Dr. Winchester. Or it could also be I Love Science actually with Year 10s. But still, I Love Chemistry with Dr. Winchester. Today we're going to look at the reactions between acids and bases. Okay, so a base is anything that reacts with an acid, and we're going to look at three different kind of reactions. We're going to look at an acid reacting with a metal oxide. We're going to look at an acid reacting with a metal hydroxide. Hydroxides are soluble, so not only is this a base, this is an alkali as well, a soluble base. And we're going to look at an acid reacting with a metal carbonate. The first thing, before we start these reactions, I need you to learn a few things for me, I'm afraid. I need you to learn the general reactions that happen here and what is formed. So I'm going to tell you now, I need you to make some kind of revision sheet and learn these, because we can't really do the questions until we know what's going to be formed. I'm going to show you, especially for the higher guys, when we talk about balance equations, that you can figure out for yourself, but the best thing for you to do is really just learn these three equations, then you know you're not going to get them wrong when you ask a word equation. So an acid, it's a metal oxide, makes a salt, which is half the acid and the metal half of the metal oxide. Okay. So we make a salt, and we make water. Now, acid plus metal hydroxide, we make a salt. So half the acid and the metal from the metal hydroxide, and we make water. Excellent. So really you just have to remember that they make the same kind of things. Acid plus metal carbonate, now just we make the carbonate contains carbon dioxide, that comes out in the reaction because it's a nice stable gas, so we make our salt as ever, our water as ever, and carbon dioxide. So pause the video, write these down, make sure you're comfortable with them before we start on the next little bit. So the first example we're going to look at is an acid plus a metal oxide making salt and water. So for an example, this could be magnesium oxide. Which I've very confusingly not put under the metal oxide, so that is the metal oxide. Now our acid could be, let's have hydrochloric acid. And we're going to make a salt from a water. So we need to think, what salt are we going to form? Well, we know we're going to make water, so that's nice. That's not exactly hard. So for the rest, the skill that we're really being tested on, if you ask for a word equation here, is to spot the salt you're going to make. Now, we know that we take half, the magnesium half of the magnesium oxide, and we're going to add it with the second half of the acid, the chloride part of the acid. Okay, so hydrochloric acid contains a chloride ion, and it combines with the magnesium ion to make magnesium chloride. Okay? That's our salt. Now the next step, they could ask us to balance the equation, or they could ask us to write a symbol equation and balance it with state symbols. So, magnesium oxide. When you think oxide is going to be the O2 minus ion. Okay, so let's start off with the O2 minus. Now magnesium, I need to know how many plus we have on our magnesium atom. So I look at my periodic table, and I see it's in group 2. So it's going to make an Mg2 plus ion. So actually if you have a 2 plus and a 2 negative, you only need one of each and you're nicely balanced and neutral, so that's what we want. Okay? So our formula for magnesium oxide is going to be MgO. Okay, this is just something I do for my work. So you can do it underneath and cross it out, or just do it away from the side so that you don't have it in the way. Our formula is neutral, so no charge, magnesium oxide. Plus hydrochloric acid is HCl. This goes to magnesium chloride now. So we still need to remember the magnesium was 2+. Now chloride is only 1-. Chlorine is in group 7, so it gains 1 electron to make chloride 1-. You need to remember chloride is 1-. So how many of these 1- do we need to balance out our 2+? We must need 2 of them. 2- will balance out 2+. So what I can do is have 2 of them. Now I know that the formula of magnesium chloride must be 1 magnesium atom and 2 chlorine atoms. I do a subscript little 2 there to show that there's 2 of those and 1 of those. Balanced out, it's neutral now. Lovely. Okay? So we've got the formulas. Okay, we don't worry about balancing until we've got the formulas correct. Plus water, and we know water's H2. Okay, now we come on to balancing. So, probably a good place to start is the chloride ions. Here on the whole left-hand side, there's only 1. On the right-hand side, I need to have 2. So, I'm not allowed to play with the little numbers once I've got them correct. So I need to say that I need 2 of hydrochloric acids. So I need 2 of these HCl molecules. So then that gives me 2 chlorines. I'm happy there. Okay? And also it makes me 2 hydrogens. And I've got 2 hydrogens there, so I'm actually happy there. I just need to make sure I'm happy with the magnesium, the oxygen. Magnesium, I have 1 there and 1 there, so I'm happy there. Oxygen, I have 1 there and 1 there. So now this is balanced. I've checked the magnesium, the oxygen, the chlorine, and the hydrogen. I have the same amount on the left-hand side and the right-hand side. So I'm balanced. Now we just go state symbols. We just need to look at what physical state, solid, liquid, gas, or aqueous, dissolved in water, we have. Magnesium oxide is a solid. Hydrochloric acid is dissolved in water. All of our acids are dissolved in water. Okay? That's why they can be dilutes. Magnesium chloride is actually, if it's soluble, which they mostly are, is dissolved in water, so it's aqueous. And water, you can either put liquid because it's liquid or aqueous because it is in water, it's water itself. Okay? So now we have a balanced symbol equation with state symbols for that. Excellent. So our second example was an acid plus methyl hydroxide goes to salt and water. So let's take a different acid this time. Let's take sulfuric acid. Sulfuric acid, we need to learn these, it's H. No, let's do the word equation let's walk before we can run. Let's do the word equation before we do the simple equation. So the word equation will be sulfuric acid plus, let's do sodium hydroxide goes to a salt. Now we need to decide what the salt's going to be. We take the metal part of the hydroxide, sodium, and we have the second half of the acid, so not the H bit, but the other bit. Sulfuric acid has sulfate ions in it, so we're going to make sodium sulfate. Plus water. So let's do the simple equation. That's done, that's the word equation done. And let's do the simple equation. Sulfuric acid is H2SO4. Sodium hydroxide. Now, when you think, before we think about what our formula about hydroxide is, we kind of need to make it up. So sodium is in group 1, so it makes 1 positive ions. Hydroxide, we need to learn this, is the OH minus ion. So 1 plus, 1 minus, these cancel out in a ratio of 1 to 1, so it's just going to be NaOH. That's not our formula, this is our formula. We use this for working out, okay? We're going to make sodium sulfate. So again, sodium is just 1 plus. Sulfate is actually a 2 minus because we've got 2 pluses to cancel out the sulfate. So it's 2 minus, SO4, 2 minus. So we must now have 2 pluses to cancel out a 2 minus. The only way we can do that is add another sodium, Na2SO4. 2 negative balances out 2 single positives. So Na2SO4 plus water. Oh, so we need to do a simple equation, so we don't write down water, we write down H2O. Okay. Let's balance this step. So, Best way to start is let's look at the sulfate ion to start with. We could do. Sulfate ion is SO4, so how many SO4 bits are there? There's one there, there's one here. That's balanced, that's good. Let's have a look at the sodium. Okay, I'm trying to look at the bigger things first. I don't want to look at the oxygen and hydrogen, they get a bit complicated. So I look at the kind of big things like the sodium ion and the sulfate ion first, because they're a bit simpler. They're only one part of the equation, they're only one of the reactants and one of the products. So sodium, one sodium here, two sodiums here. I can't play with this formula because I know it's correct. So I must put a big 2, and I can't play with this formula, I must put a big 2 in front to tell me I need 2 of these sodium hydroxide molecules. Now, it gives me, well, sodium hydroxide bits, that's the ionic. Gives me 2 sodiums, goes to Na2. We've got our sulfate sorted, it hasn't fiddled with that, but it's given us more oxygens and hydrogens here now. So let's see how many oxygens and hydrogens we've got here. Remember, we've looked at the sulfate as its own, so we don't really need to count up these oxygens as well, but I'll show you afterwards that it will balance anyway. So we have these two, this hydroxide is going to go with the H pluses from this acid, there's 2 of them, and we've got 2 OH minuses. 2 OH minuses. So OH minus and our H plus are going to go together to make a water. So 2 of that have 2 H minuses and 2 H pluses, so we're going to make 2 waters. Another way to do our last little step now, just to make sure we're balanced, is to count everything up. So let's have a count of the hydrogen ions. We have 1, 2, 3, 4. On the right hand side we have 2 times 2 is 4. Good. Oxygen, 1, 2, 3, 4, 5, 6 because of that 2. 1, 2, 3, 4, 5, 6 because of that 2. Lovely, we're balanced. Sulfur, 1 sulfur there, 1 sulfur there, we're balanced. Sodium, 2 sodiums there, 2 sodiums there, so we're balanced as well. Last thing is state symbols. It's an acid, so it's aqueous. It's an alkali there, it's soluble, so it's aqueous again. This is going to be aqueous, and hey presto, well this is aqueous or liquid. I'm going to put aqueous. Doesn't matter which, water is a liquid, and it's also dissolved in water. It is water, so it's aqueous. Lovely, that was done.